Good evening to everyone. I have been asked to welcome you to the 2020 Junior Senior Design Challenge. We probably should call this the Virtual Design Challenge. My name is Dr. Karsnitz. Many of your teachers called me Dr. K. You can ask them about that. And I'm in my home office. And as you can see over my shoulder, there are many photographs on the wall, plaques and photographs from my days at the College of New Jersey. A lot of those photographs are of students at various places, like the design challenges at Virginia Beach or at the national conferences. So they were always fun to do. Design has been the center of our program since the early 90s. Some of you may have seen the book Design, Problem Solving, and Technology that Dr. Hutchinson and I did, and then in 94, and then more recently, a design book, Engineering Design, that was done with Dr. Hutchinson and Dr. O'Brien, who's the acting dean of the school right now. So design has been an important part of the program. Design and STEM have gained national recognition clearly. Everybody knows what the word STEM means, or most people do. They think it's very important, and we feel that way as well. I think you found as you were doing your design work for this challenge that the teamwork, the research, the collaboration, the communication were all important parts of the success of your project. So it's what we do in our undergraduate programs, our technology and engineering education major, and our iSTEM major for K to 5. All those majors lead to certification to teach technology and engineering in schools. So they're really very wonderful programs, very exciting and rewarding areas of study, and of course in very high demand. So those are exciting things to do. So we encourage you to visit the website. It's istem.tcnj.edu, and you can learn a lot more about the program. There are really some neat things on that website. And we encourage students to apply to the program. Come and visit the program, apply to the program, either as a first-year student or as a transfer student. Many of our students in the past have come in as transfer students, and we have a program where we work with the students, advising them and working with them for that first year, so that when they do transfer, they come in with a full year of credit, and they are right on track to graduate in 4 years. So that's very exciting. And certainly you can speak with the department chairperson, Dr. Figueroa, or you can contact me if you would like to, and I'd be happy to speak with you. It's karsnitz@tcnj.edu. So in a few minutes, the winners are going to be announced by the department. Mrs. K and I are pleased to have sponsored the trophies for this year's design challenge. And one of them is a grand trophy that's going to be a traveling trophy. And that means the next year that trophy needs to be defended in next year's design challenge. So hopefully that would be on campus. So congratulations to all the teachers and students and parents, I think, as well, that participated in this year's design challenge. And Mrs. K and I wish you all a great deal of success. Thank you.
This first video shows how to properly remove the vaccines from the packaging. The styrofoam solution is removed from the secondary packaging box when first opened. Next, the lid of the device is removed to expose the 10 test tubes in the styrofoam which holds the vaccines. The test tubes are then removed from the styrofoam. Finally, the vaccine is removed from the test tubes while it is attached to a piece of cardboard. The tape is carefully removed from the cardboard to obtain the vaccine safely. To prepare the vaccines for shipping, first we have attached each vaccine to a strip of cardboard. The piece of cardboard and vaccine will then be inserted into a plastic test tube that is just the right size for the vaccine. Inside the test tube will be pieces of recycled newspaper to provide a cushion for which the vaccine will sit on. The cardboard has a width barely shorter than the radius of the test tube, so the vaccine will be held in place. Once all 10 vaccines are inside their test tubes, they will be placed within circular holes we have cut into styrofoam. This styrofoam will prevent the tubes from moving as well as keep it in an easily accessible area. Once they place the bottom block of the styrofoam, another block will be placed on top to keep the test tubes in place. These two blocks will be held in place solely by the test tubes, as the tubes fit snugly in place and keep the blocks together. From there, our vaccines are ready to be shipped safely off to TCNJ.
Hello, my name is Tia Christina from Team Aperture. I came up with the final design for this challenge, and when this competition was proposed, I wanted to create something that wouldn't take up too much space for the box, and you could ship as much as possible, and we wanted something that would be really resilient. For this, we took inspiration from the shape of a hydraulic shock absorber and decided that a cylinder would be the best shape to work with for this. As for its weight, we decided that having the center of it be hollow and having the material be 3D printed, it would save a lot on weight and it would be the ideal for this. We wanted the seal on the top to be easy to open, so we decided that an aluminum seal that you could just pull right off would be the best decision. It was also really important for us to use aluminum for the top, so it's easy to recycle.
Hello, we are Team Pretzel Party, and this is our solution to deliver the vaccine challenge.
Here we have the start of it all, the singular vaccine. To protect this priceless vessel, we will encase it with a paper straw to prevent snappage. The ends will be exposed for easy access to the vaccine. A total of 10 vaccines will be shipped together, all using the same method of protection. All of these vaccines will be centralized around one internal structure and will be connected via modified paper straws. This internal structure will be sheathed by an external structure and locked by hooks on each side.
We're the Brainy Bunch.
And this is our design.
To start off, we have our package, and wrapped in the package, we have inside is a layer of foam and a layer of cardstock. Next, we take the plastic water bottle, we stick it in here, and this is to make sure that our vaccines don't move around too much. And then we have our vaccines in paper straws in these penny holders to make sure they don't move around at all. And we can just line them up like this and stick them in here. Lastly, we have this final layer of foam to make sure when the cap goes on that the vaccines don't move around. This goes in here, and then we can just stick the cap on. That's our design.
After brainstorming through a plethora of ideas, our team designed a compact triangular prism to serve as the container for the trial vaccine. Each pretzel rod representing the trial vaccines is individually wrapped by black cardstock lined with soft cotton sheets.
The primary packaging ensures that the pretzel rods remain intact, as the soft cotton sheets surround the pretzel, lessening any impact.
The cardstock provides a sturdy covering, and the red tape secures the primary packaging. Inside the triangular prism, the bottom is covered with cotton, and each trial vaccine is placed vertically into the prism in their primary packaging. Cotton and newspaper protect the top of the trial vaccine.
The lid is sealed with red tape, which must be cut and or removed to reach the trial vaccines.
The end result is a sturdy prism that resists impacts, does not roll, and protects the trial vaccine. It fit easily into the shipping packaging, which was a mailer. We delivered the package to the post office and sent the trial vaccines on their way.
We are excited to see the results.
Thank you!
Hi, we're Prisms. We just participated in the TCNJ Design Challenge, and here's what we did and why.
So first, here's our design. Our main design relied on a sliding mechanism, as shown in the picture, and this primary packaging was then surrounded with paper mesh. And we chose the design because, one, we believed it would be relatively simple to use, cost efficient, and aesthetically pleasing.
We made this design by using a laser cutter and AutoCAD. We drew engravings and cuts onto cardstock and cardboard, which allowed us to make foldable shapes, which is pretty cool.
And finally, we folded all of these shapes and we put it in our primary packaging that's shown here. And then we finally shipped it in USPS to TCNJ.
Yep.
Hi, we're the Howell High School team. This is our primary packaging. We have these foam hair curlers, those are the blue and pink things, and they're attached to this thin piece of cardboard at the bottom with some thread, and there's a straw running through the entire thing. We also have this corrugated cardboard lid, as well as an aluminum sheath.
When it comes to putting our project away, we have to take our cardboard lid, pass it through the handle, take our aluminum casing, put it through again, and then into our secondary packaging for shipping.
That's it. Hi, we just sent our package. We weren't allowed to film inside the building, so there's our receipt.
A couple of days ago, TCNJ assigned us to design and construct the primary packaging for 10 samples of trial vaccine and mail it to them for final approval. We had only 3 days to do it and were constrained by many factors.
Our box is made out of number 2 HDPE plastic with a cardboard sleeve around it to prevent the lid from falling open. We have also used an aluminum rod to secure the base to the lid. Our box needs to be easy to make and manufacture, as wasting precious time on a complex box wastes not only time, but the hundreds and thousands of lives that are at stake.
If we were a real manufacturing company, we would use injection molding to speed up the process. And since our box is 100% recyclable, it can easily be used over and over again, speeding up the manufacturing process.
The primary package fit into the shipping package quite excellently.
After several hours of work, we are finally able to ship it.
Before I announce the winners, I want to congratulate all the participating schools, advisors, teachers, parents, and students. And I also want to give my gratitude to all the TCNJ volunteers from the Department of Integrative STEM Education who worked together as part of the production team, especially Professor Daguna's TED 460 class, who wrote up the challenge. The students who came to campus to film the intro videos, the challenge video, and also those that came to evaluate the submissions and plan out the logistics for the entire challenge. It was a very big team effort. The challenge itself was so timely, and I think it gives us a real taste of what's going on behind the scenes in the pharmaceutical companies and what the efforts that they are undertaking to get the vaccine out. I truly believe that just in a couple of days, that the chance that you got to work on this, you learned so much about the logistics that are going on to deliver the vaccine to everywhere in the United States. It's a complex issue. There's many layers to it, but it also takes STEM professionals from all disciplines working together to figure it out. And I think we have to really give credit because it all starts right here with all the educators who are preparing students every day to critically think about real world problems and to creatively think about design solutions. If you get a chance, join us tomorrow, Saturday, November 21st at 1 p.m. for our open house to learn more about the majors in our department, the technology and engineering education major, as well as the integrative STEM education major. It's a good opportunity to meet some of the students. Another professor will be there and he can tell you all about our program. You can find the link to register. Just Google TCNJ Lions Day and it'll come up there. Our event is at 1 o'clock, so you can find us on that website. Now, on to the competition winners. We had 6 students who evaluated your documentation, and they were there with me, and as we unpacked all of the packages. Luckily, all of them arrived, and everything turned out fine. There were really a lot of creative solutions. And ultimately, it came down to the protection of the vaccine and the overall weight of the shipping package, as well as how well your team presented your design process through your documentation. Those were really the biggest factors. So in third place, we had a team who came together and developed a sliding compartment to protect the vaccines, and they also laser engraved all their packaging, and it turned out a really nice product. With a shipping weight of 139.6 grams, the third place award goes to Team 208, the pretzel protectors from the Princeton International School of Mathematics and Science. Great job. In second place, we have a team who designed a custom triangular prism that held all 10 vaccines very tightly and well protected in that small space. With a shipping weight of 96.9 grams, the second place award goes to Team 206 from Brick Memorial High School. Congratulations. And finally, the first place trophy is going to go to a team who designed a cylindrical structure. They used 6 recyclable materials to make up their primary packaging with a total shipping weight of 37.1 grams. The 2020 Junior Senior Design Challenge winners are Team 209, the Rebels, from Howell High School. Congratulations to you guys. As you know, Howell High School will, since they won the first place, they will also get to receive the traveling award trophy, and they will have their name engraved on that trophy for the year 2020. Make sure you bring it next year. where you'll be able to defend your championship. And I hope everyone is able to return and compete again and get ready for a new challenge for 2021. Thank you so much, and we'll see you next time.